motion in a straight line. In this first we are discussing about some definitions. First one is distance. What is the distance? For example, one bus is traveling from A to B along this path. Similarly along this path or similarly along this path. Length of the path travelled by the particle is called distance. What is the distance? Length of the path travelled by the particle length of the path travelled by the particle is called distance. Is called distance. What are its SI units? Its SI units are meters. What are the CGS units? CGS units are centimeter. So this is about distance. Distance means length of the path travelled by the particle is called distance. Similarly, now you go to displacement. Now, what is the displacement? This also denoted with S. Distance is a scalar, only magnitude, no direction, and also it follows simple algebra, that is called scalar. So distance is a scalar, but displacement is a vector. Okay, how it is once you see. For example, one bus is traveling from A to B. How? Straight line along the shortest length of the path. Previously I had told like this paths. In this all of paths, AB is the shortest path, straight line. Shortest length of the path is called displacement. What is this? Shortest length of the path is called displacement. Shortest length of the path is called displacement. It is starting its journey from A position. Where stopped? B position. So from A position you take dot up to B position. Where it had stopped, there you give arrow mark. So this is the representation of the displacement. So that is called a vector. So I am taking this as small a. This length I am taking as small a. This is the direction. It is having magnitude and also direction and also following vector algebra. That is called vector. So displacement is a vector. Displacement is a vector. Vector is denoted with always bold letters or any magnitude taking and giving arrow mark on the top. That is called vector. So displacement is a vector and distance is a scalar. What is the distance? Distance is a scalar. It is having only magnitude, no direction, and follows simple algebra. But this follows vector algebra. That is the main difference between vector and scalar. So what are the SI units for displacement? Same like that only. That is meter. What are the CGS units? CGS units is centimeter. So this is about displacement. Distance is scalar and this is vector. Units are same only. Now What are the, once you go to definition, what is vector and what is scalar? What is vector? What is vector? Which physical quantity having magnitude and direction and follows vector algebra? Which physical quantity having magnitude, direction and follows vector algebra? Vector algebra means addition of vectors. Law of addition of vectors. It follows law of addition of vectors. So that is called vectors. What are the examples? Now only I had told displacement, force, acceleration. Like this number of physical quantities we are having vectors. It is having magnitude, direction and follows vector algebra. That is called vector. Now what is scalar? Now scalar. What is scalar? It is having only magnitude, no direction and follows simple algebra. Which physical quantity having only magnitude, no direction and follows simple algebra? Which physical quantity having only magnitude, no direction and follows simple algebra is called scalar. What are the examples for this? Distance, work, power, like the number of physical quantities. These all are scalars. Okay, next we go to average velocity and average speed. Average velocity first. Average velocity. For example, one particle starting its journey from A to B, again B to C, again C to D, again D to E. Like this it is moving. This total duration, year to year T1 time, year to year T2 time, year to year T3, year to year T4 time taken. Now I want to find the average velocity. What is that? Formula. Average velocity, that equals to total displacement by total time. Total displacement by total time. That is called average velocity. It is the ratio in between total displacement to total time. So what is the initial position? A. What is the final position? E. I am joining A and E. So that is my net displacement, total displacement. That only called what? Resultant displacement. That also called resultant displacement by total time, that is called average velocity. Resultant means what? Simply addition of vectors. This I am taking S1, this I am taking S2, this I am taking S3, this I am taking S4. Now what happens totally? S1 vector magnitude plus S2 vector magnitude plus S3 vector plus S4 vector. Otherwise, if this is totally represented by S, this you write as S, that your wish. By total time. What is the total time? T1 plus T2 plus T3 plus T4. So this is called average velocity. Otherwise, this is called resultant displacement S by T1 plus T2 plus T3 plus T4. That is called average velocity. From A to E, total journey, total displacement by total time. That is called average velocity. Next, average speed. Average velocity and velocity formula same only. Well, what is the formula for velocity? What is the formula for velocity? First we are going to velocity. Average velocity means I had told already this. So, what is the velocity? What is the formula for velocity? Velocity. It is denoted with V. Velocity is a vector. What is the formula for velocity? Displacement by time. Displacement by time. Otherwise, you write this as ds by dt. Small displacement, small time. Displacement, time. Anything else same. Rate of change of displacement. What is the meaning of this? ds by dt means rate of change of displacement is called velocity. What is the velocity? Rate of change of displacement is called velocity. Rate of change of displacement is called velocity. What are the SI units? This is meter and this is second. So meter per second. And also CGS units. Centimeter by second. So centimeter per second. This is about velocity. Otherwise, you write another definition also. What is that? Particle traveled displacement in 1 second. That also goes to velocity. Another definition what? Particle traveled displacement. Particle traveled displacement in 1 second. If this is 1, displacement equal to velocity is called velocity. So this is about velocity. Previously only I had told average velocity. Next you go to speed. So your dimensional formula also comes. What is the dimensional formula? What is the dimensional formula for this? Length L, time T, always writing with brackets, square brackets. T coming upward, then what happens? T power minus 1. Totally what I am writing here? LT power minus 1. Generally dimension formula writing in the MLT. Here M not mentioned, not affected. So I am writing as M power 0. L T power minus 1. These are fundamental physical quantities. What are those? Mass, length, time. And not only those, remaining also 4 also there. Mass represented with M. Mass M. Length L. time t. These are the fundamental physical quantities. Generally, these are representing these only. But to explain some physical quantities, derived physical quantities, remaining four also we are using electric current and intensity of light, like the things. So this is about velocity. Next you go to speed. Next you go to speed. Next you go to speed. Speed also denoted with v, but this is a scalar. What is the formula for speed? Speed equals to distance by time. Distance by time. Rate of change of distance is called speed. Otherwise, particle travelled distance in 1 second. Particle travelled distance in 1 second is called speed. SI units, CS units, dimensional, all same like that, velocity only. This is a scalar and that is vector. This is a scalar. This is a scalar. Now what are the SI units? Meter per second. Distance meter times second. CGS units. Centimeter per second. Distance centimeter times second. Dimensional formula. What is the dimensional formula? L by T. L by T. So T coming here. Then what happens? T power minus 1. Same like that only. M not affecting. That I am taking power 0. Means no affecting. Independent. So M power 0, LT power minus 1. This belongs to speed. Now we are discussing about average speed. Now we are discussing about average speed. Average speed. What is the formula for average speed? Total distance by total time. Total distance by total time. That is called average speed. What is average velocity? Resultant displacement by total time. Add total. Same like that only. This here distance taking, there displacement taking. Everything same only. This is average speed. Next, instantaneous speed. Instantaneous speed. What is the instantaneous speed? For example, one particle traveling like this in a short distance, short time interval. Particle traveling very short distance in short time interval. That speed is called instantaneous speed. Instantaneous speed means that you take as instantaneous velocity only. Because if the length becomes small, distance becomes into displacement only. So you write this as, so generally what telling instantaneous velocity word using. Due to this only what we are using this word? Instantaneous velocity. Why? If the length becoming small, arc also considering as a straight line. Due to that happens. So instantaneous velocity word perfectly using. So what is the instantaneous velocity? Limit. I am taking this distance as a delta x. This I am taking as delta t. Then what happens? Limit delta x by delta t as delta t tends to 0. This we are writing as dx by dt. That is called instantaneous velocity. At one particular instant, what is the velocity? That is called instantaneous velocity. Next, velocity classification. Velocity classified into two types. One is uniform velocity. Another one is non-uniform velocity. What is the uniform velocity? In equal time intervals, 1, 2, 3, 4, like this. In equal time intervals, traveled displacement same. For example, here 2 meters traveling, here also 2 meters, here also 2 meters. So here what is the distance? Displacement 2 meters. Duration 1 second. So 2 meters per second, that is called velocity. This is called uniform velocity. In equal time intervals, traveled displacement is same. That is called uniform velocity. What is non-uniform velocity? Here you take 1 second, 2 second, 3 second, 4 second. In the first 1 second duration, it is traveling 2 meters. Next it is traveling 3 meters. Next it is traveling 4 meters, like that. In this, what is the duration? 1 second. What is the displacement? 2 meters. So in this duration, what is the velocity? 2 meters per second. Similarly here, 3 meters per second. Here, 4 meters per second. In equal time intervals, traveled displacement is different. That is called non-uniform velocity. What is uniform velocity? In equal time intervals, traveled displacement is same. That is called uniform velocity. Same like this, speed. Speed also we are considering like this. Speed. Uniform speed. And this is non-uniform speed. What is uniform speed? In equal time intervals, traveled distance is same. That is called uniform speed. What is non-uniform speed? In equal time intervals, traveled distance is not same. That is called non-uniform speed. Speed in which case comes? For example, one car traveling along a curved path, that goes to speed case. It may be uniform or non-uniform. That things later. One car going along straight line, that goes to velocity. So these are the physical quantities